Now let's just go ahead and write the JavaScript logic for finding the nth root of a number using the binary searching technique that I have explained earlier. So here what we will do, we will define the search range. For that, we will have left and right, and then we will calculate the middle, and based on the results we will limit our search to left part of the search range or to the right part of the search range, or we directly return the middle, right? So here left I am going to initialize it with 1. Similarly, I will define one more variable right. This I am going to initialize with the value of the m itself. Here ultimately we need to find the nth root of a number, right? That means that we need to find a number such that if we perform that number power n, it should basically yield the result of m. That is the reason why here the right search range would be equal to m. That means this total search range will be from 1 till m. Now immediately we will also define one variable called middle that I am initializing it with -1. Internally what we will do, we will run a loop as long as left is less than or equal to right. Immediately what we will do, we will calculate the middle. Middle is nothing but math.floor of left plus right divided by 2. Once we have this middle, what we will do, this middle can be the nth root, right? So what we will do, how we will confirm that, we will basically perform the middle power n, and if it is equal to m, that itself is the nth root of the number, and we can return that. So here first of all, let me just create one variable called result. To this, what I will do is I will call the power function from math library. Here I will pass middle, and I want to calculate the middle power n, right? So I will pass the arguments as middle comma n. If at all the result that we have gotten is equal to the value of m, middle itself is the nth root, so we can directly return the middle. If this is not the case, there would be two scenarios, right? In which we either need to search in the left part of the search range or on the right part of the search range. When we will get to search on the left part of the search range, whenever the result is greater than the middle. So we need to search in the left part of the search range. So what we will do, we will update the right to middle -1. If this is not the case, obviously result would be less than mid. In that case, we need to increase the result value. So it should be there on the right part, right? So to search on the right part, we will update the left to the middle +1. In the end, we will return -1. Why? Once we complete the execution of this while loop, we have not found a valid value. So there is no nth root of the given number. So we directly return -1. That is the binary search based solution for finding the nth root of a number. Now to test this, here the values of n and m I have passed are 4 and 81, and created the object of the class that we have written, and using that object called the function with the value of n and m. In the end, whatever the result it was returning, we are capturing it and printing, right? Now if I just analyze this, I know that if I do 3 power 4, we will be getting 81, which is nothing but 3 square 9, 9 into 3 is 27, 27 into 3 is nothing but 81. So ideally the output that I am expecting is 3. So let me just run the logic and see. The output that we have gotten is -1. Why it is -1? Let's just go ahead and let me just do this, and let me just run the logic, and still we are getting -1. Else if result is greater than. So I understood the issue why it is not running. Here we should compare the result is greater than m, right? Not mid, because the value of m we have already gotten. So we need to compare it with the value of m. That is the reason why we were getting -1. So after modifying this, if I rerun the code once again, see the output that we have gotten is 3. Okay, just a comparison issue was there. That is the reason why we were not getting that. But anyway, now that is fine, right? Now let's just go ahead and let's make this as 85. We know that there is no number. If we get that number to the power 4, there is no number which will yield a result of 85. So if I run this, I should be getting -1. -1 is what we have gotten. Here let's just assume I have passed 2 and the result I have passed is 100. Now we know that 10 square is nothing but 100, right? So if I run this, ideally the output should be 10, and 10 is what we have gotten. For example, here I have passed only 1. So ideally 100 power 1 is nothing but 100, right? So output should be 100. So if you see, output is 100. Okay, let's just say here I have passed only 10 and here I have passed 3. So there is no number whose power 3 will yield a result of 10, right? So it should return -1. So -1 is what we have gotten. Okay, similarly, you can pass any value in n and m based on the nature of the values that you are passing. Either you will get absolute nth root of that number, or if the nth root of the number is not available, you will be getting -1. Okay, so that is the effective way internally, basically using binary searching algorithm to find the nth root of the given numbers.